In this video, I'm going to show you how to use sign charts to analyze different problems. So take a look at this question here. Solve the inequality x minus 4 over 2x plus 1 is strictly less than 0. So if this were equals to 0, we'd clear out denominators, multiply by 2x plus 1 on both sides. But because this is an inequality, it's a little bit trickier. And so the best way to do things is to make a sign chart. Let me draw a number line here. We're going to ask, when do things kind of, when we might use the word cut points. Where do we have to cut the line? And we're going to cut the line when like the numerator and denominator give us 0. So x minus 4 is equal to 0. Gives us x is equal to 4. That will be a cut point. 2x plus 1 is equal to 0. 2x plus 1 is equal to 0. Solve that. That will give us x is equal to negative 1/2. So we have two cut points. X is equal to negative 1/2, and x is equal to 4. So what we're going to do is that we're going to test points in different regions of the number line. Less than negative 1/2, between negative 1/2 and 4, and bigger than 4. So let's think about that. And so we're going to test x is equal to negative 1. Negative 1 is smaller than negative 1/2. If we plop in negative 1/2 up into this expression, we would get negative 1 minus 4 over 2 times minus 1 plus 1. That's going to be negative 4. Negative 1 minus 4 is negative 5. Over 2 times negative 1 is negative 2. Plus 1 is negative 1. Negative 5 over negative 1 is positive 5. And so this is strictly bigger than 0. This is not what we want. So the inequality is false here, not just at x equal to negative 1, but at all values of x less than negative 1/2. Now we test at a point between negative 1/2 and 4. Let's test that x is equal to 0. So this would be 0 minus 4 over 2 times 0 plus 1 is negative 4 over 1 is negative 4. And yes, this is negative. And so because this is negative, this is a good thing here. So not just at x equal to 0, but at all points strictly between negative 1/2 and 4, the inequality is true. And then finally, let's test something to the right of 4. To the right of 4, we would have x is equal to 5, let's say. And plugging in 5 up here, 5 minus 4 over 2 times 5 plus 1 is equal to 1 over 11. And that's positive. That's not what we want. We want it to be negative. So inequality is false, not just at x equal to 5, but at all x values bigger than 5. At x is equal to negative 1/2, this expression is undefined. X equal to 4, this is 0, not strictly less than 0. So the interval that this is true on is negative 1/2 to 4 exclusive. So this use of a number line is a pretty useful little trick to help you analyze what's going on. One more example here. Write the domain of f of x in interval notation. F of x is 1 over x the square root of x squared minus 4x minus 5. And so what we are looking for here is that we want x squared minus 4x minus 5. We want this to be, this can't be negative. because we can't take the square root of something negative. And if this was equal to 0, we would be dividing by the square root of 0, 0. So we want x squared minus 4x minus 5 to be strictly positive. So how do we analyze this? Again, we need cut points. How do we find the cut points? Let's factor. We can factor x squared minus 4x minus 5. This can be factored as x minus 5 times x plus 1 is greater than 0. And so we see our 2 points are 5 and negative 1. Okay, so now we just have to check at different points here. To the left of negative 1, between negative 1 and 5, and bigger than 5. So something that's less than negative 1, we have x is equal to negative 2. This expression would be negative 2 minus 5 is negative 7, times negative 2 plus 1 is negative 1. Negative times negative is something positive, so that works. The inequality here is true. For x's between negative 1 and 5, let's just use x is equal to 0. 0 minus 5 is negative 5. 0 plus 1 is 1. Negative 5 times negative 1 is negative, so it's false between negative 1 and 5. And then bigger than 5, this would be x is going to be, we can test x is equal to 6. 6 minus 5 is 1. 6 plus 1 is 7. That's positive, so this is true again. So it's true for x values less than negative 1. It's true for x values strictly bigger than 5. So the domain, the part that is less than negative 1 is negative infinity comma negative 1. And then union sign 5 to infinity. Open parentheses because we don't include the endpoints. Okay, so hopefully these examples of using the sign chart were instructive.